Hello, welcome to Mr. CFD. In this video, I'm going to show you how to generate the geometry and mesh of this product heat transfer in pipe with twisted tape inserts. To start generating the geometry, first open a workbench window. Wait for it to be opened. As you see, workbench window is opened like this, and from this toolbox, analysis system, you can select fluid flow fluent and drag it to the blank window. And then you see there are some sections, for example, geometry, mesh setup, etc. I want to open geometry in SpaceClaim, so right click on it and then open a new SpaceClaim geometry. So a SpaceClaim software is open like this, and now I want to start drawing the geometry. First of all, I use line command from sketch section, and from the center of the coordinate, draw a line in which the length is 15 millimeters. And actually, I want to generate the tape inside the tube. But the thing is that I consider actually the length of the tape actually longer than the real one, because after generating the solid of twisted tape, I will remove it from the pipe, so the length and the size of the first tape that I want to generate is not that important. And you will see how I want to generate it. So here I'll show you how to continue drawing the other parts. And now go to Pool Tool and select the line that you have created. Select Revolve and then select Y-axis so that the tape would be generated around this axis. And here from this box, actually options, activate helix. And here the height of the twisted tape actually should be 2200, but I said that I want to make it bigger than the real one, so I put 2500, and the switch pitch would be 110. So yeah, put the values. So as you see, the tape is produced like this. Actually, it is the half of the twisted tape that you want to generate inside the pipe. To generate the other half, again, keep pull option. Then actually pull it about 15 millimeters. And now we have the complete tape that you want to put inside our tube. And you see here the surface is created. Okay, to continue, click on this line and make a sketch like this. Click on it, and then using circle command, draw a circle from the center in which the diameter is 22 millimeters. Then go to 3D mode to see the surface of the circle is created. And now it's time to give thickness to the tape. To do that, select Pool Tool, click on the tape surface and pull it about 1 millimeter. Enter. So now, as you see, the surface of the tape is converted to solid. As you remember, I said that the size of the tape actually is not real because we want to remove it from the pipe. So first of all, try to move the circle surface. Click on move, and in this direction, move it about, for example, 8 millimeters. The length is not important. And now it's time to actually make a cylinder as the pipe. So click on the circle, activate no merge, and then extrude the circle about 2200 millimeters. So you see, now we have two solids, the tape and the tube. Now it's time to remove the tape from the tube. To do that, go to Combine command and first choose the tube, and then choose the tube, and then choose actually select cutter, and then select the tape as the cutter. So yeah, now we have four solids: this one, the tube, and this one, and this one. So we want to delete the tape. So right click on it, delete, and then this one. This is the half solid of the tube, and this is the other part, and this part should be selected too because it is the tape again. So right click on it and delete. And now the geometry is complete, and if you go to select section, you can spin your geometry, and as you see, the tube is made of two solids, this one and this one. and the twisted tape is removed from the solids. Finally, go to Workbench section and click on Share to check if there is any coincidence topology in the model, but it says that there is no one, so it's time to close the SpaceClaim window and then transfer it to Ansys Meshing. After closing a SpaceClaim window, you can see green check mark is activated for geometry, meaning that the geometry has been generated correctly. And now you can go to Mesh, double click on it to start Ansys Meshing software. Now the geometry is transferred to Ansys Meshing window, and if you zoom in, you can see, yes, the geometry is here, and now we can start meshing. First, click on Mesh in this section, and make sure that physics preference is on CFD. Now it's time to give element size for the whole geometry. To do that, details of mesh, and here element size would be 2 millimeters. And then for choosing method of meshing, select body of this toolbar, and then select this body, right click on it, insert and method. Here the body is selected and method should be on sweep method. The algorithm is on program controls, and the element order is global setting. Should be chosen manual, and I should choose a surface as a source of sweep method meshing. So I use this surface, apply, and in next step I want to have layering mesh on this surface. To do that, select this surface, right click, insert inflation, and choose these two edges as boundary, and I want to have a layering mesh with these setting up smooth transition with the default transition ratio and maximum layers of 5 and growth rate of 1.2. Okay, go for next body to set the sweep method. Again, right click, insert and method, sweep, the source target selection should be on source, manual source actually. The source is the surface. Free face mesh type is on quad tri, and yes, it's done. And now it's time to have layering mesh or inflation on this surface. To do that, again select this surface, right click, insert and choose inflation. Then as the boundary, choose these two edges, apply. The other settings are default. And now it's time to right click on mesh and click on generate mesh, so the process of meshing starts. So the meshing is done, and if you spin the geometry, you can see how the meshing has been produced on the surfaces and inside the body, like this, and how the layering mesh is produced on these edges on the surfaces that are going to be actually inlet, and also the faces that are going to be outlet. And if you right click on mesh and update, the mesh transition to fluent is possible. You can close Ansys Meshing and go for fluent setting. Hope this video is helpful for you. To benefit from Mr. CFD services including simulation, consultation, and training, visit our website www.mrcfd.com or contact us via info@mrcfd.com.